So when we first saw the poster for the Vertical Flight Society design competition, we all thought it was crazy because it was really difficult. We had to develop an aircraft by using as a propeller system the area screw made by Leonardo da Vinci in the 15th century. So it was really hard to try to do something like that. But then we understood that by taking part in this type of competition, we could develop real-world practical skills. So apply those theoretical knowledge we got from university and put that in practice. So we took part in the competition as PoliScrew. The team was made by me, Alberto Chiozzi, Gianni Curti, Edoardo Chisalè, and then Luca Colombo, Giuseppe Di Stasi, and Matteo Di Pilato. We all worked together in order to try to make something, to put all the ideas we had and build the aircraft. So I suggest to all of you to try to take part in this type of competition because are really helpful and are really good for try to put in practice those knowledge. So now I think it's coming. Yeah, it's arriving. Yeah, it's really huge. It's 10 meters large and it's only weight 130 kilos. So it's really huge. The screws were really huge. They were 4 meters in diameter and 2 meters high, and they only weighed 24 kilos each. So really lightweight. The skeleton was made in carbon fiber and all was covered up by spinnaker, a special fabric used in the sailboat industry.
The main structure of the screw is inspired by the tower cranes. In fact, as you can see, it has a true-slide core. With this configuration, we were able to reduce the surface facing the airflow during the advanced motion, and so also the aerodynamic drag. It is made up of aluminium alloy 1775, and the main properties are the lightness, a good resistance to both shocks and twists, and a good bearing of the temperature changes. On the back of our rotorcraft, you can see our rear propeller. It is a conventional double-bladed rotor with an eigenefficiency, which is about 75%, and it is made of carbon fiber. It provides 25% of the total lift and the moments to control the aircraft, such as the pitching one, which is produced by changing the angular velocity of our rotor, and the yawing one, which is produced thanks to the small stepper motor inside the final part to the fuselage, which can bend the rotation axis on the left or on the right to change the flight direction during the hovering phase.
The fuselage is designed to be as light and stiff as possible. It has a unibody canoe-like structure. It's made of high-strength carbon fiber, and its length was optimized to both well housing the pilot and all the electrical and mechanical devices. The team removed material where it was possible and not required from a structural purpose. The team chose to use the MRAX 188 AC motors. There are 3 motors and 1 for each propeller. These motors have the best ratio power to mass we could find. In fact, they developed an astonishing 52 kilowatts of power for only 7 kilograms of force, of weight. The motors are linked to the screws by a double pulley system with a ratio of 1:9, and the system lowers the RPMs of the motors, maintaining the torque.